Theorem 5.18, L'Hopital's rule. Let f and g be functions that are differentiable on an open interval AB containing point C, except possibly at C itself. Assume that g prime of x does not equal 0 for all x in the interval, except possibly at C itself. If the limit of f of x over g of x as x approaches c produces an indeterminate form 0 over 0, then the limit as x approaches c of your function f over g, that will be equal to the limit as x approaches c for f prime of x over g prime of x, provided the limit on the right exists or is infinite. This result also applies when the limit of f over g as x approaches c produces any one of the indeterminate forms with an infinity over an infinity. The negative and positive signs can vary. Let's look at an indeterminate form where we have 0 over 0. In this top limit, we have the limit as x approaches 0 for e to the 2x minus 1 over x. Notice a direct substitution of 0. E to the 2 times 0 is 1, minus 1 is 0. In the denominator, a direct replacement with 0 is also 0. And so we get a 0 divided by 0 form. Applying L'Hopital's rule, that says we can take the derivative of the numerator. Using chain rule, that's 2e to the 2x. This negative 1 goes away. The derivative of the bottom of the fraction is 1. And so now we have the limit as x approaches 0 of 2e to the 2 times 0. Well, when we sub 0 in for x, that totals out to 2. The limit at the bottom is the other indeterminate form, the infinity over infinity type. For natural log, remember how that graph hooks kind of upward and out? As x gets larger and larger, natural log will also grow. The denominator x will get infinitely large, so this is a case of infinity over infinity indeterminate form. Let's apply L'Hopital's rule. We can take the derivative of the numerator, which is 1 over x, the derivative of the denominator, which is 1, and that simplifies to 1 over x. As x approaches positive infinity, 1 over x approaches 0. Another indeterminate form is 0 times infinity. I'm going to take this e to the negative x term to the denominator so that I can make my negative become positive. Now we have the limit as x approaches infinity for square root of x over e to the positive x. Square root of x gets larger as x gets larger. E to the x also gets larger as x gets larger. And so this is an indeterminate form now of infinity over infinity. And so that's the strategy you want to use if your indeterminate form isn't initially 0 over 0 or infinity over infinity. With some manipulation, you can usually get it into a form where it's one of those two. And so now, instead of 0 times infinity, we now have it in an indeterminate form where we can apply L'Hopital's rule. Take the derivative of your numerator using chain rule. That's 1/2 x to the negative half times 1. That's 1/2 x to the negative half. The derivative of our denominator, e to the x, that remains e to the x. So I've taken the derivative of top and bottom using L'Hopital's rule. Carefully transform your problem. This 1/2, I'm going to drop the 2 to the denominator. X to the negative half, when I drop it to the bottom, it'll be x to the positive half. And I'm going to return it to square root form. You can leave it with a power of half if you like. Now all the variables are in the bottom. As x gets infinitely large, this denominator will too. If your denominator gets really large, the value of your fraction becomes 0.